Example 2, notice we have our parentheses once again. This time we have two sets of parentheses. And again, if this problem is sitting in my book just like this, what I might want to go ahead and do is, as I copy to my paper, go ahead and distribute as I copy it. 3 times 1 is 3. 3 times positive 2x is positive 6x. Plus 7 is not in parentheses. Nothing happens to it, so it stays right where it's at in relation to the equal sign. Equal sign goes next. Be careful with the distributive property that this sign along with the number is being distributed. So when I multiply this through, negative 4 times x is negative 4x. Negative 4 times positive 2 is negative 8. So be careful that when you distribute, make sure the sign and number are getting multiplied using proper multiplication sign rules as you do it. Step 2 is to add like terms on left and right hand side individually. So here's my left hand side of the equal sign. Here's my right hand side. Looking at both of those boxes individually, the left hand box, 3 and 7 are like terms. So 6x has no like terms. 3 plus 7 makes 10. I'm adding these because the signs are the same. It doesn't matter that they're separated by that 6x. Positive 3 and positive 7 being like terms on the same sign. Add together. Equals. On this side, this has next, that doesn't, so there are no like terms in that case. So that's all step 2 is, combine like terms. After step 2, every problem should look pretty much like this. At most, a letter and number equals a letter and a number. All right? Next step is I'm going to move letters to one side, numbers to the other side. Again, the way I make my decision for which side I move things to, the x terms. Positive 6, negative 4, positive 6 is bigger, move to smaller. Once I decide 4x goes over there, and again, as I move it across the equal sign, the sign changes. Negative 4x becomes positive 4x. If x's are on that side, that means numbers are on this side. Positive 10 moves across as a negative 10. I go ahead and line up my like terms. One bad habit that some students have that I want you not to have, and let me just point this out real quick. I see a lot of people do this. Let's write plus 4 instead of plus 4x. And they write 10x down here. So they're like, what's the big deal? I don't care. I'm still getting the right stuff. But this might give you a mental thought of, I can add 6x and 4 together, because you can't. All right? So if you're moving a 4x over, make sure you keep that x attached to it in your work. Over here, negative 8, negative 10. And again, this is subtracting 10, but this is subtracting 10 from a negative 8. The signs are the same, so I actually add the numbers and keep it negative because 10 is bigger than 8. So make sure you're adding when you're supposed to add, subtract when you're supposed to subtract. The signs are whatever they are, but then the signs determine whether you add or subtract based on their sameness or differentness, I guess. So, same sign you add. And then finally, divide both sides by the coefficient of x. 10 times x, divide by 10, that leaves x equals. Now this also is an improper fraction, but it's a reducible improper fraction. Do get into the habit right now of reducing fractions whenever possible. I do realize sometimes you don't realize that some fractions are reducible. The numbers get so large, like I don't know if that reduces, so I'm just going to pretend it doesn't. But if you just think through a little bit, what I do to decide whether or not a fraction is reducible, if I can't just tell right off the bat, I look at the smallest number there is, 18 and 10, 10 smallest, right? Consider the factored form of 10 prime factors. Then I look at each individual prime factor. Does 2 go into 18? Oh yeah, it does. All right? And then I know if it reduces. Does 5 go into 18? No, it doesn't. So it only reduces by 2. And just like that, I get a reduced fraction. It's not too terribly difficult. Again, there's usually at least one smaller number in a fraction. So just take this prime factor form of the smaller fraction, smaller number, and divide it into the top. And if it divides evenly, it reduces by that.